Welcome to our third PyHealth's live tutorial. I'm Zhenbang Wu. I'm currently a CS PhD student at UIUC, advised by Professor Song. And in this tutorial, I will introduce you some classic and health-specific deep learning models and demo how you can easily utilize those models with PyHealth. PyHealth is a deep learning for health toolkit designed by Professor Song's team, including Chaoqi, Patrick, and me. And we also want to thank our external collaborators, Yue, Dr. Chao, Dr. Cao, and Xiyang, for their contribution and discussion. So first of all, for those who are new to PyHealth, it is a comprehensive deep learning toolkit for health predictive tasks. It is developed to support both machine learning scientists and clinical practitioners. It has 4 key features, including supporting a wide range of EHR databases, such as Mimic, EICU, or other OMAP standards, and also including providing the API for multiple healthcare tasks and hosting a bunch of classic and health-specific deep learning models. And lastly, providing the lookup and mapping functionalities for multiple medical coding systems, including ICD, STOMAP, and NDC code. So to utilize PyHealth, we introduced this 5-stage machine learning pipeline, which is pretty standard for machine learning. So it starts from data pre-processing, that is this step 1 and step 2, where we process different data sets into a uniform format and use a certain task function to transfer data into a task-specific samples. And so this is covered in our previous tutorials. And you can, for a recording, you can check out our YouTube video for that. And for tonight, I will cover the rest 3 steps. That is this model selection, and then training, inference, and evaluation, with a focus on the model part. So let's start with the model input. Let's take a single patient as an example. So let's take a look at this patient whose patient ID is 12853, and is a male patient whose age is 77. So let's assume this patient has 3 visits in a database. In the first visit, this patient is admitted to the emergency department with a condition of acute embolism, and he was treated with a few procedures, including blood test, ultrasound, CT, and ECG, and given a medication. And however, the situation for this patient may getting worse, and this patient is later transferred to ICU with more severe conditions such as atrial fibrillation, respiratory failure, and heart failure. And this patient was conducted with this respiratory ventilation, meaning this patient is probably in some danger. But luckily, this patient got recovered, and then later he was transferred to the general hospital admission, and then given some more further diagnosis and procedure, and then later was discharged home. So that's a example patient trajectory in any EHR database. In our previous tutorial, Chachi covered how we're going to generate a unified samples from those raw data for a certain task. So in this figure shown below are the samples generated from this patient for the mortality prediction task. As you can see here, it recorded the corresponding patient ID, gender, age, and age. That's the patient demographic features, and also including those clinical features, including conditions, procedure, medications, which is recorded as a list of medical codes. So let's take this condition as an example. It is a list of 3 lists, where each of the lists in the inner loop corresponds to a single visit, and the medical code are the condition code from those visits. And lastly, it records label information, that is mortality. And because this patient is discharged home safely, the mortality label is false. So from these generated samples, we can now define our model. We will take recurrent neural network as an example. So first of all, as you can see in this bottom figure here, we initialize the RNN feature with the following arguments. The first argument is this dataset equal to samples, where we essentially feeding all the samples into the model. This is for functionality such as building the code to index mapping or defining the label space. And for the second argument, we define what are the features for these models. So here we use the conditions, procedure, and the medications as the features. So this string corresponds to the keys in each of the samples. And thirdly, we define this label key as mortality. That is, we telling the model we are going to predict mortality for this using this model. And this task is a binary prediction task. So we set its mode equals to binary. And next, I will explain a little bit behind the thing of this recurrent neural network model. So RNN is featured by its recurrent feature. That is, the current steps depending on the output from the previous step. So for example, let's first take a look at these condition features. And in this figure, we show a RNN models unfolded in the time axis. As you can see here, there are 3 visits. And if we take a look at the second visit, it takes the medical code, the condition code of the second visit as input, as well as the output from the first visit. So that is the recurrent nature of this RNN model. And we do the same for both conditions as well as other features, that is the procedures and the medications. So we have 3 RNN models, one for each of the features. And then we concatenate the output at the final time step of each of the recurrent models into a long vector. And then we're gonna feed this long vector into a fully connected network. That's usually a multiple layers of linear layers plus different activation functions. And these fully connected networks will output a single logic, that is the predictive mortality logics. So that is a little bit behind thing of this RNN model. And with PyHealth, we provide you with access to many different models, ranging from those classic deep learning models such as MLP, convolutional neural network, recurrent neural network, and transformers, to those deep learning models specifically designed for healthcare tasks, such as Retain, GameNet, Micron, and SafeDrug. We will add more models in the future, and all those models are using a similar API. So in these 3 figures on the right, I show how to init 3 different models with a very similar steps. That is feeding the datasets, defining the feature key, defining the label key, and tell the model what's the type of task you are going to do. And of course, you can further input some other arguments that is specific to the model. For example, for RNN, you can define how many recurrent layers you're going to do, whether it's bidirectional or not, and some other arguments like dropout or something. So that is the model part. And further, to make it more flexible, we also provide you with this layer API. So I will first use PyTorch as an example. So in PyTorch, we utilize it in 2 different minors. The first one is we sometimes use some existing models provided by PyTorch. For example, here I can initialize a ResNet 50 models or a swing transformer using PyTorch. So those models are already for those models, the architecture are already specified, and it only takes a specific types of input as the model input. But the second way we utilize PyTorch is using those torch.nn layers, such as those convolution layers, max pooling layer, or recurrent layers, to build our own models. So our PyHealth package also provides a similar functionality. That is, if you want to use some existing models that is published in previous research papers, you can simply call our PyHealth.models.specific model name, such as the previous RNN model or some other models we listed in our previous slide. And another way you can utilize PyHealth, and it is a more flexible way, that is, you can build your custom models with PyHealth layers. We provide a layer for each of the models, including our package. That is, RNN has a corresponding RNN layer, and Retain has a corresponding Retain layer. Here I show an example with the Retain layer. As you can see, it takes 2 arguments, which is a feature size and a dropout rate. So these 2 arguments, as you can see, are completely not dependent on the other parts of our package. So it can be directly used in any of the pipelines, as you can see in this example here. So after you initializing the model, you can use it in a very similar way to those layers in torch.nn, and this can be directly plugged in to any other models or pipelines. So this is to provide you with even more flexibility of using PyHealth in your own work. So let's take a look at these PyHealth models. As I mentioned earlier, we provide 2 types of callable methods for each deep learning models. The first one is the model API, such as RNN, CN, transformer, Retain. And the second one is the layer API, which can be used independently from the other pipeline of PyHealth and can be incorporated into any other deep learning models you design. So as I mentioned earlier, for each of the model, it needs 4 basic arguments. The first one is this dataset argument, which is essentially a dataset object, and it is used for some model-specific processing for the dataset. And the second one is this feature keys, which is a list of strings-based key names. And the third one is this label key, and the fourth one is this mode, which actually tells what type of task the function, what type of task the model is doing, either multi-class, multi-label, or binary. And further, we also accept different arguments for the different model layer, such as input size, hidden size, type, number of layers dropout, or other things. This is model specific, and here we use the arguments for the RNN layer. So let's take a look at some concrete examples. So first of all, we have to initialize the OMAP dataset, and now we are using the synthetic data. And as you can see here, is the dataset samples we just created. For more details, you can refer to our previous live tutorials on the dataset and samples. And next, I will show you two different ways to use the model or the layer. The first one is you can use the model as a whole. That is, you use the entire retained model, where you just input the 4 base arguments as well as some model-specific arguments, such as this embedding dimension. And then the model just initialized, as you can see here, are the following layers for the retained model. And the second option is that you use retain as a layer. This is very similar to the torque.nn layer, which can be incorporated into your own customized model. Here, we just show one example of using the retain layer in the middle, which are accompanied by a few different layers, this module 1 and this module 2. This can be any other layers that you design for your own model. In this very last step, we show an example using the transformer model. As you can see here, despite their different models, the API are very similar. And actually, we use the same API for all the models we incorporated in PyHealth. So if you run this code, you can see here we initialize the transformer models. And similarly, you can also use the transformer layer as an independent layer and incorporate it into your own customized model. So that's the PyHealth models.